Group 7, the halogens. Today's lesson objectives will be to describe the properties of the halogens, how they look at room temperature and pressure, what their physical state is, what color do they form in water, and can we make predictions about their reactivity and explain it? That's the higher level. So here are some starter questions for us. How many electrons do group 7 elements have in the outer shell? What is the bonding in a diatomic molecule? Is it covalent, ionic, metallic? What does it mean in regards to boiling points down the group? Thinking about structures. So you can pause here and have a think about it, but we're going to move on to the answers. So group 7 elements will have 7 outer electrons because the group number tells you the number of outer electrons. Therefore, they'll have similar chemical properties. They will all want to gain 1 electron to form a -1- ion, which we call a halide. So, for example, fluorine will be called fluoride. Chlorine will be called chloride. Now, diatomic molecules, as you should already know, form a simple molecular structure with covalent bonds between the atoms, but weak intermolecular forces between the molecules. So inter means between molecules. So the boiling points are generally low, especially compared to metals. They have giant metallic lattices. So therefore, weak intermolecular forces of attraction will require little energy to overcome. Now, as you go down the group, if you remember, I mentioned this in the group 1 lesson. In group 1, the metallic bonding got weaker, so the boiling point went down. Here, the boiling point actually increases because as the atoms are larger, the molecules are larger, so you get stronger intermolecular forces of attraction, which would require more energy to overcome. So this is from the bonding topic. So all very important background points. Now, what's a halogen? A halogen is something which is salt producing. That's where the word came from. Because when they react with, say, group 1 metals, they'll form salt. The most famous being sodium chloride, which we would use for our food. Here you can see a picture of them as you go down the group from left to right and then down. Chlorine being the smallest, then chlorine, bromine, iodine, astatine. Now, they're found obviously here in group 7. Now, if we consider their melting points, we can actually see it here. We can see the trend. Notice how they're getting bigger in our pictures, and notice how the melting and boiling point is increasing. So that means at room temperature, which is considered 25 degrees in chemistry, the first 2 are gases. Then we have a liquid, and then we have a solid, which obviously means astatine will be a solid. Now, all of them are non-metals and they don't conduct electricity. Now, this font hasn't come out very well. So what I'm going to do for this section is I'm just going to show you the answers of the common questions and answers notes that you have, because this has the essential points. As you go down group 7, the colors get darker. And the first one, chlorine, is a green gas. Bromine is a dark red-brown liquid. And iodine is a dark gray solid, which makes astatine a black solid. Now, that's their normal state. When you put them into water, so that you bubble it through water, they'll partially kind of dissolve and they'll form an aqueous solution. So chlorine, not much surprise there, it goes from a green gas, it turns to a very pale green solution. Bromine, now this is important. Remember, bromine is orange and iodine is brown. Just stick to those 2. Forget about what your revision guide might say. These are accepted in mark schemes and they'll make your life a lot easier. It also makes it easy because for the organic topic where we test for alkenes, we say bromine water is orange. Okay, then this is a reminder that oxidation is loss of electrons and reduction is gain of electrons, so oil rig. We will need this when we do the displacement reactions, but that will be done in the part 2 lesson. For this lesson, we now need to discuss what happens down the group in terms of reactivity. So if you think about drawing them out, so we could try that here. Say we drew fluorine. There's fluorine. Then we do chlorine. Say we drew bromine. They'll each have 7 in the outer shell. Okay, imagine they each have 7. What are they trying to do? They're trying to gain 1. Now remember, the nucleus is positive. Which one is going to be able to gain the electron the quickest with the least amount of energy? Obviously fluorine, because fluorine is the smallest, so it'll have the strongest nuclear attraction. This one, nucleus, is very far away from the incoming electron, so it'll be much harder for it to gain the electron. That's why down the group, they get less reactive. So group 1 got more reactive, group 7 gets less reactive. Don't confuse the two. The explanation is almost the same. The only difference is the last part, because they're trying to gain, not lose. So if we go to the next slide for the detailed kind of description. Atomic radius gets bigger down the group. The incoming electron is further from the nucleus. The double shush. There's more shells, more shielding. Remember, the shells are repelling each other, and they're shielding the nucleus. There's a weaker nuclear attraction towards the incoming electron, so it is harder to gain an electron. Remember that the increased nuclear charge still gets outweighed by the increased shielding. Now, oxidizing ability of the halogens. So an oxidizing agent is one which makes you oxidize. So if I'm going to oxidize you, I'm going to remove your electron because oxidation is loss. So I'm taking your electron. So I myself are getting reduced. So it's a bit like opposites. Oxidizing agents are getting reduced. They're trying to gain an electron. So if you think about it, the best oxidizing agent will be fluorine because it's the smallest, so it gains the electron the easiest. So the oxidizing ability of the halogens, just like their reactivity, decreases down the group because there's less attraction towards an incoming electron. So it's harder for them to oxidize other things. Okay, then we could play a little quiz. So thumbs up, true, thumbs down, false. They get less reactive down the group. True. False. True. False. True. True. Okay. Next lesson, we're going to look at the halogen displacement reactions, which will be the last part of this topic. So see you next time.